What is up, guys? Today we're going to be covering familial lipid disorders. So there's four kind of main familial lipid disorders that's very high yield and important to know for your board exams. And all of these, they're called familial because all of these basically act under a mode of inheritance that can be transmitted down your family line. Of the four, two of them are autosomal dominant and two of them are autosomal recessive. And I'll show you a little mnemonic to help remember which are autosomal dominant. So then by basically then the other two must be autosomal recessive. So let's get right into these four diseases. So the first one is hyperchylomicronemia. So I want to start off by saying that in this video, I'm not going too much into actual details of lipid metabolism, just looking at the diseases. I'll probably release another video explaining lipid metabolism, kind of simplifying it, because there's a lot of really vague details and it gets really picky in a lot of the details of what lipoproteins and what apolipoproteins are on what and where the receptors are and what it does. So this is just going to kind of be an overview to help you remember how to recognize the diseases, and then when looking at lab results, how they present, and then little tips to remember each of them. So let's get right into this. The first one's hyperchylomicronemia. For this one, it says it. You always look at the name. Like if you're looking at diseases, just read the disease and see what it's saying. Hyper, so increased, chylomicronemia. Anemia is referring to the blood, and chylomicron. So you're having an increase of chylomicrons in the blood. So I literally look at two things in this. First of all, I use the C in chylomicron. And I use that because this disorder it's gonna be caused from one of two things. It's either gonna be that you have a deficiency of lipoprotein lipase. So just quickly, lipoprotein lipase is the enzyme that's at capillaries, and chylomicrons are being carried. They carry triglycerides and cholesterol. Coming from the intestines after it's been broken down by lipases. So they have triglycerides and cholesterol inside. They meet these capillaries, which are at tissues all over the body. And lipoprotein lipase this enzyme is at the capillaries, and when it encounters a lipoprotein lipase that's there, it will basically allow the triglycerides and then the cholesterol to come out and be converted. When it does enter into that tissue, then it'll be changing the triglycerides into the free fatty acids. So it can't get to the tissue. If this doesn't happen, then basically it can't get to the tissues, okay? So you're going to have a buildup. When it's taken into the tissues, it's therefore leaving the blood. So if you can't get the triglycerides into the tissues, that means the remaining in the chylomicron remnants, I'm sorry, not the remnants, just the chylomicrons, and then therefore you're going to see an increase in triglycerides. You're obviously also going to see an increase in chylomicrons in the blood. Now that's one cause. The other cause can be that an ApoC2 deficiency. Now this is another reason why I said the C is important. When you think of hyperchylomicronemia, think of that C for chylomicrons. So in this disease, think of the C to help you remember ApoC2 deficiency. Now also the C could help you remember that ApoC2 is needed at the capillaries. See, another C. And the capillaries, like I just said, C2 is the receptor that helps it to go to this site and react with lipoprotein lipase. So you're either lacking the enzyme at the capillaries, or you're lacking the actual ApoC2 on the chylomicron. Both of these are needed for kind of the same purpose. The ApoC2 is needed to be able to recognize and get to lipoprotein lipase at the capillaries, and the lipoprotein lipase actually does the function of sending what the chylomicron's holding, which is triglycerides and cholesterol. But right now, let's just think of the triglycerides, and sending and converting it into free fatty acids, which can then leave into the tissues, okay, from the capillary there. Now, there's a very important thing you need to remember about this disease, and I'm going to show you why. It's going to be, when you look at lab results, you're going to only see an increase in triglycerides, but it's very specific. It's going to be greater than 1,000 triglyceride when you look at the lab value. Now, coming up, I'm going to go to the next slide just to show you quickly. In familial hypertriglyceridemia, you're also seeing an increase in triglycerides, but it's for a different reason, but this one's not over 1,000. So we'll get to that in a little bit. All right, and how is this going to present? Well, when you have triglycerides, there's a theory that really, really high triglyceride levels, when they're then in the plasma and then they're slowly converted into free fatty acids, all of that acid can cause recurrent pancreatitis. So that's a common symptom that's in hyperchylomicronemia. That's kind of unique among the other ones. All right, so the next one is familial hypercholesterolemia. Let's look at the title. Let's just read the disease name. Hyper, increased cholesterolemia. Increased cholesterol. So in this situation, you have no LDL receptors. I didn't say no LDL. I said you don't have the receptors. So therefore, the receptors is what helps the LDL to be converted and cleared out of the body. I'm not going to go into all the details of how that happens. Just know that without the receptors, you can't get the LDL. You can't convert it into other types of the lipoproteins, and you also can't get it out of the blood plasma. So you're going to have really high LDL levels in this disease. Now, familial hypercholesterolemia, I'm going to jump down one thing from autosomal dominant. This is the disease that they love to ask about this one a lot because it presents with really early heart attacks in patients. So if they have a family history, let's say, for example, a patient has a father who had a heart attack at 52. That's not necessarily uncommon. Like, that's kind of when heart attacks tend to happen in patients who are sedentary, have diabetes, bad diet, etc. But if you have a patient whose father had a heart attack at 28 or 30, that's very, very rare. And so they'll kind of set that up in this situation because this disease of really, really high LDL levels, therefore high cholesterol levels, causes early onset MIs because the LDL is the main one holding all the cholesterol. It has one of the highest percentages of cholesterol of the lipoproteins. And the cholesterol can then go into when it's circulating on the body, that's what causes atherosclerosis. So really LDL is linked to the heavy levels of atherosclerosis, which then therefore, if that happens in your coronary arteries, that can cause a myocardial infarction. So I said all that to say this. This is the one that this is very dangerous. This causes death, and it can be early death due to MIs and various complications related to that. So death, I think whenever I read familial hypercholesterolemia, I know that can equal to death, so that helps me remember autosomal dominant, the one most related to early death. Okay? Because a lot of these other ones, they don't have, you may even have a normal lifespan. Like for the first one, hyperchylomicronemia, you can have a normal lifespan if you can take triglyceride medications. So, this is going to cause increased LDL, and this is the only one of the main lipid disorders that do this. So that's unique to know. So lab results, everything else is cool except for the cholesterol, and then you see increased LDL, that's really high. You need to be thinking of familial hypercholesterolemia. All right? Let's look at the next one, the third one, familial Dysbetalipoproteinemia. There's a D, familial D for Dysbetalipoproteinemia. This is autosomal dominant, D for dominant. So now we already have the two that are autosomal dominant. That means the other two are autosomal recessive. So remember, I told you the way to remember the first one. In hypercholesterolemia, there is early death. This is the one that can cause death, D for death, and then therefore D for autosomal dominant. And then in this one, it literally has dysbeta, it has D at the beginning of it. So that helps you remember autosomal dominant. Now the problem in this one is that you have an ApoE2 subtype instead of ApoE. Now let's backtrack and remember that in this disease for familial Dysbetalipoproteinemia, the ApoE is what is going to help basically with uptake into the liver, basically with triglycerides and cholesterol specifically. So the ApoE2 subtype is involved with that on the apolipoprotein. Specifically that you're going to have increased remnants. So now a remnant is just a chylomicron that has had a lot of the other stuff taken out. But if you still have to use the ApoE2 to be able to specifically control levels of cholesterol and triglycerides. So what is going to happen? They could tell you have increased chylomicron remnants, and then you would have increased of the cholesterol and increase of triglycerides. Increased remnants, increased cholesterol, increased triglycerides. Okay? And it's because of increased VLDL. Increased which is very low density lipoproteins. All right? That one's more, this is one of the ones that kind of gives me more of a problem, and it's more difficult to remember. But if you can remember a lot of the other ones and how they present, you can kind of begin to break it down and just have this one left in the answer choices. And I have a question at the end of this that I wrote that I'll show you what I mean. And the last one is familial hypertriglyceridemia. This is related to this. The reason for this disease that it happens is because of increased VLDL secretion or decreased VLDL uptake. And this is going to cause increased triglycerides. Do you remember at the beginning I said that this one also has only increased triglycerides? But the difference is this one must be greater than 1,000. This one has a triglyceride level that is very, very high. This one will not be over 1,000. So if you see an isolated increase in triglyceride levels that's not over 1,000, you need to be thinking of this one. And the cause of this is increased VLDL secretion or decreased VLDL uptake. Okay, increased VL. So in other words, you're sending more VLDLs out from the liver, which is responsible for sending out VLDLs, or you have decreased uptake of VLDL. Okay, so either of those can be the cause of this one, and you're going to see increased triglycerides in this disease. All right, here's a question. You can pause the video and read it, and then I'll go ahead and start reading the question and go through the answers. A 32-year-old male patient presents to his primary care physician for an annual health checkup. A history of hyperlipidemia runs in his family, and his father died of an MI at 62. Now let's start breaking this down. A history of hyperlipidemia runs in his family. Okay, his father died of an MI. His father died of an MI at when? At 62. Right away, this doesn't sound like the description for familial hypercholesterolemia. Remember, that was the one I said, the D for death, because it has early MIs, a family history of early MIs. That's not really seem to be happening here, but let's keep reading. His BMI is 32, and his diet consists of frequent fast food intake because of his long hours on the road as a truck driver. He is in no active distress and has no complaints. The following lab tests are collected and reviewed with the patient the following week. The relevant tests are shown, or results are shown below. So, you don't have to memorize. I mean, some of these would be good to memorize, but a lot of times they'll put like a little range next to it, and they'll say like normal is this or whatever. But some of these are kind of high yield to know. But just looking at this test result, you can kind of already tell this is out of whack. And I'll just go ahead and tell you, the HDL above 40 is considered normal. It's okay. They prefer a little higher, but that's normal. LDL of 91 is normal. A1C is actually elevated. A1C, remember, is involved with how glycosylated your hemoglobin is, so that's a sign of diabetes. So in other words, this patient probably has diabetes. And then a cholesterol 175, so cholesterol below 200 is normal. So this is normal. HDL normal, LDL normal, but triglycerides are elevated. So you have an isolated triglyceride level, but look at the level. It's 655. So remember, in type 1 that we talked about, so do you remember which one type 1 is? It's the hyperchylomicronemia, the familial hyperchylomicronemia. That's the one that has the triglyceride levels above 1,000. So go ahead and eliminate. So it's asking you, which of the following best explains the lab result findings? Let's eliminate, first of all, what I just said, that it has to be a triglyceride above 1,000 to be familial hyperchylomicronemia. So we can eliminate whichever one of these are describing that. So let's go through. LDL receptor absence. What is that involved in? That's involved in the one that has early death. Familial hypercholesterolemia has an LDL receptor absence. Therefore, you have really, really high LDL levels, and therefore you have tons of atherosclerosis, and that's why you'll end up having early MI, a family history of early MI, or the patient could have had an early MI. So this is not the answer because, let's look, why is it not the answer? Because the LDL is normal in this patient, so this is wrong. What about an ApoE2 subtype? Do you remember which one I said has ApoE2? I don't remember if I told you this. So first of all, ApoE2 subtype is involved with, right here, familial Dysbetalipoproteinemia. I didn't point this out to you, and this is really helpful for me. Beta, so when I read Dysbetalipoproteinemia, I look at beta, and I just kind of think of, I almost pronounce it as Dysbetalipoproteinemia. So beta kind of makes me think of bi, and bi is another word for 2. So that helps me remember the ApoE2 subtype instead of the normal ApoE. Alright, so this is saying, is it an ApoE2 subtype abnormality? Well, no, because an ApoE2 subtype abnormality, look, you would have increased cholesterol, increased triglycerides. So let's look at his cholesterol is not given, so we assume it's alright. What about triglycerides? Well, triglycerides then 655, but the cholesterol, there's nothing mentioned here, and it doesn't really fit the description. So, oh, I'm sorry, cholesterol is right here. Cholesterol is normal, so it can't be that, sorry. So, B is wrong. What about C? The disease causing these lab findings is autosomal dominant. What are the autosomal dominant diseases that we mentioned? Do you remember? It's the one that starts with the D, the Dysbetalipoproteinemia that we just got done eliminating from the answers. Dysbetalipoproteinemia is one of them, and then I said early death. Which one has early death? Familial hypercholesterolemia. Those are the two that are autosomal dominant. Familial oops, misspelled that. I'm just gonna get a little period. You know what I'm trying to write out right there. So those are the two. These are the two that are autosomal dominant. So this one though has just an increased triglyceride level. That's all it has. So clearly none of those are under that category. So it's no. The disease causing these lab findings is not autosomal dominant. What about an ApoC2 absence? Which one has an ApoC2 absence? Remember I said when you see the C, you need to be thinking of capillaries. And if you know a little bit about lipid metabolism, you'll remember that lipoprotein lipase is what's located at the capillaries, and that is involved with when the chylomicron reaches there. So this is involved with chylomicrons. When chylomicrons, which is holding triglycerides and cholesterol, when they reach to the capillaries of the various tissue that needs basically the triglycerides inside the chylomicron, it helps to pull in the triglycerides by converting them into free fatty acids so the cells there can use it. So the ApoC2, so that disease is specifically with triglyceride levels. So, okay, well, yeah, we have a triglyceride level, but remember what I said. The triglyceride level must be above 1,000. This is only 655. That can't be the answer. There's only one left that it could be, and clearly we've eliminated all the other ones. Problems with VLDL secretion. Because, remember, that is the one that is called, which one? It's familial right here. Familial hypertriglyceridemia. And so this is a very high triglyceride level, but it's not over 1,000, and it's due to an increased VLDL, which stands for very low density lipoprotein secretion, or decrease very low density lipoprotein uptake. And this is going to lead to increased triglycerides, but not over 1,000. So the answer is E. All right, so I hope this video helped you. Like I said, I know I didn't explain the lipid metabolism, kind of the cycle of explaining where does ApoE2 kind of fit into all this? Where does VLDL come from? But that's kind of more, it's very detailed in lipid metabolism. I may make another video explaining all of that. This is to just help you memorize the diseases, which they would tend to ask more than they would about specific details like the apolipoproteins on the surfaces of the various things and whatnot. So I hope this helped you. If it did, please like, subscribe, and share the video, and I will see you in the next video. Bye, guys.